This is a landslip that occurred in Storm Desmond, and it's still moving now. We're now the 10th of January, and here the water that's coming at the top that actually caused the landslip. I'm using that to explore how we can change the flow in the river, how we can move it from one side to the other and prevent erosion of the banks. So really just using this as an experimental area, which is really nice to have at this stage. This section here I put cross stream groins, so here the direction of flow is coming down here, coming down this way. So again the water comes in here and it goes out through the stones, it gets pushed out through the stones, so it digs this area deeper. When I first put them in, the water was coming round this corner, so this stone is important. So what happens in this corner seems to be critical to make it go across. If the stones are also put from that angle into that angle, it seems to increase the process. So the angle of the stone also looks critical. This is another area here. You can see how this bit's dug out here. So again, it's the water's come across here through these gaps, and so this part is being dug out. If that stone wasn't there, I think that would have been a lot deeper. So we'll take that out for next time. So here's 3 groins across the stream. What's happened with them is they've silted up. They've been digging out behind, they've silted up behind the stones and moved the stream across. This is an interesting little groin made out of stakes, pieces of wood behind. So this leaks the water through underneath. So the water comes in at the back of the stakes, and then it comes back through the stakes this way. And what it appears to have done is dug quite a bit deeper on the downstream side of the stakes. This is a little stake down, and here the idea is the water comes here, it gets pushed by the stakes back across this way, and it builds up sediment behind. So it digs out this part here a little bit deeper. On this section I've just tried with 2 groins across the stream. So the water flow is coming this direction. Here the water comes in behind these 3 stones and it gets pushed through. So it digs out this lower part here. It seems to be important to protect this area here, because if you don't do that, the water goes along here and around the top. So this one, and then so this is bringing the water here, it's coming through this way, pushing it this way, and then this one here, the idea was that this one pushes it back again this way. This is a form that Christine Sindelar from Austria is using, and here the flow is coming downstream, so it's like an inverted funnel. The funnel faces upstream, and with this one some water comes through the middle, but most of it comes around here and then it pushes through the gaps between the stones, and it was making a big hole here and digging this deeper. But it's not so wide at the bottom, the angle is a lot less, and this one it hasn't dug out as much, so that's an interesting one. And then next to it I've got a funnel coming downstream, which is very like the work that Ottman Grober's working with in Austria, and this speeds up dramatically the water flow here. And it's also sedimented on that side and sedimented on this side. So the idea of this is to deepen the channel in the middle, and then eventually it builds up the banks. So it's a really good thing to do instead of dredging. It's a good alternative to keep the the river deep. It also, when it's coming down, the water goes in a vortex, so it digs out the base in that way. This is a little funnel facing downstream, so the water's coming in at the wide end and it's coming out at the bottom end, and I've also added 3 stones to make it more like a Y. So what was happening when I first put these in was the water comes into the top of the Y, it gets concentrated into the narrower part and goes a lot faster. And then I put the 3 stones at the end because they divert the water. So it comes in here, goes along here, gets faster and faster here, and then these 3 stones across make the water shed this way, and they push the force of the water that way. And here also the water's come around the end and dug out the end. This is another downstream funnel. So this is again, water's coming from this direction, coming down through here. So it's speeding up the water, and here it's dug this area a little bit deeper, and then I put in another cross vein here, so that's pulled it back to this side. So it's interesting, this Y shape looks like an interesting possibility, but if we take the Y shape out, so if I'd taken those 3 stones out, you can see the speed of the water increases along at that point. This is a mini check dam using timber stakes and then putting timber across them. So this is very similar to the work they've been using in Pickering in North Yorkshire, and also Michael Kravic in Slovakia has been using this technique. In Slovakia they put in thousands of check dams, leaky check dams made out of timber, and made a very big difference to the runoff and protecting a lot of land. Here are another 2 mini check dams where you can see the silt has built up overnight, so it fills in behind the check dam, but the water is still flowing over. So here it's quite a high step check dam, and the water is dropping into the pool, making the pool deeper, and it flows on, the sediment catches, and it drops over the next check dam. What we haven't done here is put there is like a mini check dam here, and a mini one below that, and a mini one below that. So what we're talking about here is lots of series of check dams as we go down the stream to slow the flow. And it also tends to catch some sediment, so it's a way of stopping the sediment getting into the river. One of the things with the check dams is that they need to be lower in the centre of the dam and also always leak. So here we've got a series of step dams, of check dams that go down one after the other, and the bottom of one check dam is level with the top of the next check dam. If we go use our ideas and take these into the river, I'm looking here, we found a series of rocks here, which is a vein, and that's pulling the water away from the bank. Very successful. Another area here, these are the rocks, you can see they're changing the direction of the water in the river. Here's an area like a groin that's been facing upstream, and this has caused the sedimentation behind it, collecting the gravel in the background. So again, what we've been looking at is happening in the river. Here we've got some larger rocks in amongst the big gravel, and this has acted like a groin and collected the gravel bank behind it. These 3 rocks here coming into the bank have acted like a protection for this area behind it, and it's actually pulled in this gravel behind it. So the water coming in behind the rocks and then going through the gap in the rocks takes the pressure away from the bank and allows it to deposit behind it. This is River Lune near Newton. Here the bank has been armoured with these big rocks, and what's happened is the big rocks, once the river water's got behind the big rocks, the water's been actually pulled into the bank and caused this massive big erosion area here, because the rocks are in at the bank higher upstream and they go out into the middle of the river. You can see in the river there's a line of rapids, and that's where the old rocks are. So there's a big area here, probably 20 meters, that's been dug out of this bank. This is an area just on the south edge of Kendal, and here there's some big rocks that were part of the bank protection. And what's happened with these rocks is they've actually, because they're going from upstream next to the bank to out into the middle of the river, they've pulled the river into the bank and washed away a massive amount of gravel here. So this is sediment that goes downstream, causing problems. And also, because of the angle of them, they've helped deposit gravel on the other side of the river. So this is a way, if we actually use the stones at the right angle, we can actually get a deposit of gravel to build up a bank and change the river course by using these big rocks within the river rather than along the bank. Another area in the river, here's an area where it's like a funnel running down the river, and the river has collected gravel to one side of it and the other side of it. Then we move to this area. Here we've got a line of stones which comes down from the bank and out, and this, rather than pulling the water away from the bank, it's pulling the water into the bank. And then you can see the effect of this downstream where it's washed away the ford. And then the alder along the bank is another way of protecting the bank. So these alder trees are built up, the seeds of the alder tree float and they spread themselves along the bank. So this gives us some idea of how we can protect the river, protect the bank, so we can use in very successful river restoration. So how can we use this information? The main thing is that we can work with the river, the forces of the river. So if we have an erosion problem where the bank's eroding, we can use in-stream training of the river to take the river away from the bank and stop it eroding more. Or if we've got an area that needs dredging, we can put in an area where the river gets deeper, just using the flow of the river. Or we can use the alder trees that let their seeds fall along the riverbank to protect them. So rather than spending a lot of money on very expensive armouring of the banks, we can do it all in the centre of the river. The other thing that we can use it for is for really looking at the way that we observe what's happening in the rivers. So if we can find an area where there's been erosion, just look at where the rocks are in the river, see what's caused it, see what the function is. If we see a pile of rocks on the riverbank or silt that's been collected in a particular area, why is that being collected? So use your observation skills, and then hopefully we'll get more work of this done in Britain.